Okay, so let's talk about some general mathematics mistakes. So these are, ever since I've been in the education system, these are the mistakes I see the most common mistakes that's always made. So when we have 2x plus 2, the final answer is supposed to be 2x plus 2. Think about it this way. If you have a group of A's and a group of B's, you cannot say I have a total of A or I have a total of B. You need to say I have my group of A plus my group of B. That's why our answer remains the same. Another very common mistake would be x multiply x squared. This gives me 2x squared. Well, this is totally incorrect. What's supposed to happen is x to the 3. So you have an invisible one there. You have a 2. You just plus these two to give you 3. Another common mistake I would see is, especially with graphing of functions, where you have y is equal to mx plus b. So let's say we have the f of x is equal to 2x plus 4. A very common mistake would be to start at 2, go 4 up, 1, 2, 3, 4, 1 right, and then graph the function. And in this case, we're supposed to start with our y-intercept. We're supposed to start over here. So we start with 4, we go 1, 2, and 1 right, and there's our function. Another common mistake when it comes to function is that, let's say we graph some type of function. Let's say we have the f of x is equal to x squared. It would be to not, this is a very small mistake, but it has detrimental consequences. You don't add little arrows to the end of your line. Why is that? Because, well, a line has 2 arrows pointing left and right. A ray has 1 arrow, and a segment have no arrows. So these are, or has no arrows, excuse me. So these are 3 different things. So when you are graphing a function, you're pretty much not graphing a line, you're graphing a segment. Okay. Now, although this might not be, it might not seem like a big deal, it's a very big deal, because this shows there's some end to my line. But if I do this, it means I'm continue going up until infinity. Okay. So another very, very common mistake that I see is when you have, let's say we have a financial question where A is equal to P multiply 1 plus R over N NT. So this is the formula for compound interest. One of the most common formulas is that students never change the R to a decimal. Okay, so never change the R to a decimal. Very important. You can just simply say 0.2. This will give me 20%. And also another common mistake that students make quite often is not multiplying the n, so the term, right? So a term in this case would just refer to things like, well, once a year or annually, 6 times, half a month, monthly, annually. Then we have daily, which would be 365. And for the financial part of mathematics, so let's look at some more general common mistakes. Another common mistake would be to, let's say you're given the square root of x, and we are supposed to, so there's currently an invisible 1 and there's an invisible 2, so we can rewrite this as 1 over 2. What a lot of the students sometimes do is they rewrite this as x to the 2, which is obviously a little bit incorrect, mathematically stated. Some more common problems that I always see is that 4 is equal to 8. Sometimes when this transfers from the left side, so this is the left hand side, to the right hand side, it gets subtracted on this side too. So in that case, which is wrong. Okay, we'll talk about why it's wrong now. In this case, then it will be 4. So therefore, x is equal to 2. That's not what you're supposed to do. You're supposed to add 4 on both sides, because we're trying to cancel this term and that term. So that gives me 4x is equal to 12. And so we have x is equal to 6. And then another one that's very interesting is the difference between a geometric and an arithmetic sequence. So arithmetic and geometric, let's talk about this one, because this one's also quite oftenly mistaken, where you have 100, 150, 200. If you can see a repetitive common difference, we can just see simply this is an addition of 50. So we can now conclude that anything arithmetic is a constant addition or subtraction. For geometric, it's, let's say we have 2, we have 4, we have 8, we have 16. So this would be a common multiplication of 2, and of 2. So for geometric sequences, well, you can just assign an addition or subtraction, but sometimes there's a little tricky one. It would be something like this: 4, 9, 16. So this is neither, it's not a geometric nor an arithmetic, since we follow no common ratio, which would be this, would be a ratio, and this would be difference, common difference. So I wanna highlight one or two more things that often occurs in lessons. The division of exponents. Now, I'm not too sure why this is very difficult to understand, but I often see that these problems don't get solved correctly. Oh, let's talk about this one as well. This one is a big problem. Yeah. So this is a very big problem. Big problem. So these are things to avoid when doing these type of mathematics, or at least, again, at a high school level. So in this case, you sort of want to break this up into two different equations. So what is 2 divided by 4? Well, I'm left with 1 over 2. Well, what is 7x divided by 2x? Well, I'm left with x raised to the 5th. Why is that? Because when exponents divide, you can simply subtract them. In theory, it might look something like this: x times x times x times x times x 7 times 1, 2, 3, 4, 5, 6, 7, 8 over x times x. If I take away 2, I need to take away 2 here, so I'm left with 5 x's. So x to the 5. What about a power? Well, sometimes this power just gets multiplied in, so my answer would be x squared plus 4, or x squared plus x to the 2. Now this is incorrect. We want to avoid this, because what power means is just two of the brackets that's next to each other. Okay? In this case, we have x squared plus, following a FOIL method, plus 4. So this is my final answer, and not just multiplying into the power. So before you start with mathematics in a very serious sense, as soon as possible, try to identify these common mistakes that you make. Go to your educator, tell them this is my common mistake, and usually they'll have a solution.